Hello everyone, how are we going today? Hope all of you guys are staying safe and healthy. So here we are at chapter 21. Let's go ahead and talk about what's in chapter 21. We're going to learn about electrochemistry, chemical change and electrical work. We're going to review what are the redox reactions, and then we're also going to talk about electrochemical cells, voltaic cells, cell potential, free energy and electrical work, electrochemical processes in batteries, corrosion, electrolytic cells. So these are what we're going to be talking about in this chapter. Okay, we have come across redox reactions in general chemistry 1. Basically, we talked about oxidation and reduction. So what is oxidation? I hope you guys remember that we can remember oxidation and reduction using oil rig. Oh, trying to get my pen to work. Okay, there you go. Oil rig. OILRIG. Oxidation is loss. Oxidation is loss. And R stand for reduction. Reduction is gain. Oil rig. Okay, so if you remember that, you know what's happening in oxidation. So in oxidation we are losing electrons, and in a reduction we are gaining electrons. Oxidation is a loss of electrons, reduction is the gain of electrons. These processes occur simultaneously. If somebody loses an electron, somebody has to be there to gain that electron, so it has to happen simultaneously. What is happening during an oxidation? Oxidation results in an increase in oxidation number. Oxidation number increases. For example, let's say we have sodium chloride. Trying to get my pen to work. Why? Okay, come here. Sodium, right? Sodium, in the general, sodium exists as oxidation number 0. So if sodium loses an electron, we call it as an oxidation, losing. The last electron is written in the right side of the equation. So the oxidation number increases. So 0 will become +1. And somebody has to be there in order to take this last electron. Let's say you have a chlorine. Chlorine is going to gain that electron and become Cl minus. So right now it is 0. Now gaining 1, make it Cl minus 1. So in a reduction, oxidation number decreases. In an oxidation, it increases the oxidation number. While reduction results in a decrease in oxidation number. You see, this is oxidation. Increase the number, reduction, decrease. This can go from 0 to +1, +2, +3. And this can go from 0 to -1, -2. And similarly, it can also go from -1 to -2. Or -1 to 0 would be an oxidation because the number increases. Okay. And we are also going to learn two terms, oxidizing agent and reducing agent. Oxidizing agent is the one that helps the oxidation to take place. Oxidizing agent takes electrons from the substance being oxidized. Now here sodium is being oxidized and chlorine is going to take that electron. So chlorine is basically helping for sodium to undergo oxidation. So who is the oxidizing agent? That's going to be chlorine in this example. Okay, so the oxidizing agent takes electrons, so take this one electron from the substance being oxidized. Oxidizing agent therefore reduced, right? Because since chlorine is helping sodium to oxidize, by gaining that electron, oxidizing agent reduced. Now we also have a reducing agent. Gives electrons to the substance being reduced. Reducing agent is therefore oxidized. Now who is going to be reducing agent here? Reducing agent gives electrons to the substance being reduced. So chlorine is going to reduce. Somebody has to give electron for chlorine to reduce, meaning to gain an electron. Who's giving that electrons? Sodium. So sodium is the reducing agent. Remember the two terms. This process is oxidation because sodium losing an electron to gain sodium plus 1. Process is oxidation, but who is the oxidizing agent? Chlorine is the oxidizing agent. Oxidizing agent is chlorine. Okay, but this process is oxidation. Similarly, this process is reduction. But who is helping the reduction to take place? Sodium. So sodium is the reducing agent. Okay. Sodium undergoing oxidation, which is the reducing agent. Chlorine undergoing reduction, which is the oxidizing agent. Okay. Yes. Summary of redox terminology. Let's look at with this example. Here in this test tube you have some zinc metal and you put hydrochloric acid. So you can see some bubbling takes place. So when you add hydrochloric acid to zinc, what's happening is you have zinc and you add hydrochloric acid. It's gonna make zinc chloride and hydrogen gas. Okay. Sometimes we just write only the ions or the atoms that actually involve in this process of oxidation and reduction. And you can balance this to hydrogen. So nothing will happen to chlorine, so you're going to keep it 2H plus, giving you zinc 2 plus plus hydrogen. Okay. That's the equation that you are seeing over here. So zinc solid, when any element or any metal or any gas is not has not formed a compound or by itself the way that we find in nature, their oxidation number is 0. We talk about this in General Chemistry 1. Remember we had a little chart to show you the oxidation numbers. So zinc is by itself as a solid, so the oxidation number is 0. And then the hydrogen oxidation number is plus 1. Okay. Remember group 1, group 2 we learned their oxidation numbers. Group 1 oxidation number plus 1, group 2 plus 2, group 3 plus 3 and so on. So hydrogen is plus 1 when it is combined with a non-metal hydrogen chloride. So chloride is minus 1, hydrogen plus 1. So hydrogen is plus 1. And zinc is zinc chloride. So chloride is negative 1. There are 2 chloride here. So the zinc is plus 2 oxidation number. And then the hydrogen here, H2 gas. So the oxidation number for hydrogen is 0. Okay. So what's happening over here? Process. Oxidation, 1 reactant loses electrons. Now who is losing electrons? Zinc going from 0 to plus 2. Hydrogen goes from plus 1 to 0. So 0 to plus 2, has the oxidation number increased or decreased? Increased, right? So if it is increased oxidation number, remember that is oxidation. And that loses electrons. Oil rig oxidation is loss. So zinc, since its oxidation number increases, zinc loses electrons. Okay, oxidation. The blue one, zinc loses oxidation. If zinc is oxidation, zinc is the reducing agent. Reducing agent is oxidized, zinc. Zinc is a reducing agent and becomes oxidized. And in oxidation, oxidation number increases. Zinc to zinc 2 plus. Oxidation number of zinc increases from 0 to plus 2. What's happening at the reduction? Other reactant gains electron. Who is gaining electrons? Hydrogen go from plus 1 oxidation state to 0. Oxidation number decreases by gaining electrons. So the hydrogen ion gains electrons. So then the hydrogen ion is the oxidizing agent because it's undergoing reduction. Hydrogen is the oxidizing agent and becomes reduced, this hydrogen ion. Oxidation number decreases going from plus 1 to 0. Oxidation number of hydrogen decreases from plus 1 to 0. Okay. Excuse me. Half reaction method for balancing redox reactions. Half reaction method divides a redox reaction into its oxidation and reduction half reactions. This reflects their physical separation in electrochemical cells. So in an electrochemical cell, oxidation and reduction are being separated into two compartments. Okay. This method does not require assigning oxidation numbers. Half reaction method is easier to apply to reactions in acidic or basic solutions. And here are the steps in the half reaction method. First thing we're going to do is we're going to divide the skeleton reaction into two half reactions. We identify which one is the reducing substance, what is the reduction, and what is the oxidation. Each of which contains oxidized and reduced forms of one of the species. And then we're going to balance the atoms and charges in each half reaction. We first balance atoms other than oxygen and hydrogen, then oxygen, then hydrogen. When we are balancing, first we're going to take our skeleton reaction. We separate them into oxidation and reduction, two reactions. And then we're going to balance. When we are balancing, we keep oxygen and hydrogen to balance last. First, you balance any other atoms or elements in our reaction. When we try to balance oxygen and hydrogen, we choose oxygen to do first and then the hydrogen. We also need to balance the charge. Charge is balanced by adding electrons to the left side in the reduction half reaction and to the right side in the oxidation half reaction. Excuse me. Remember, reduction is gaining. If you are gaining something, it has to be in the reactant side. And oxidation is the loss. So when you lose, that lost electron is placed in the product side. If necessary, multiply one or both half reaction by an integer so that number of electrons gained in reduction equals the number of electrons lost in oxidation. At the end, number of electrons lost and gained need to be equal. And then add the balance half reactions and include states of matter. Let's look at this example. Okay. Now this is our reaction that is given to you. We have dichromate ion, we have iodide giving us chromium ion and iodine. First we need to divide the reaction into half reactions. We need to choose the same species. Now chromium here, meaning it could be either oxidation or it could be the reduction. We don't know, we just separate them first. Dichromate ion goes to chromium ion, and then the other half reaction would be iodide going to iodine. Okay, and then we balance the atoms and charges in each half reaction. We first take this one. Remember, what are we going to balance first? Atoms other than oxygen and hydrogen. So balance atoms other than oxygen and hydrogen. Here you have Cr2O7. Negative 2 is the charge of the ion giving chromium, right? Cr. So there are two chromiums here. So this side we have only one, so you have to put 2 here. Okay, so the chromium atoms are now balanced 2, 2. We have 7 oxygens, or 7, there are 7 oxygens. So how do we balance oxygen? We balance oxygen by adding the same number of molecules of water, because each water molecule has 1 oxygen. So to balance this 7 oxygen, you add 7 water molecules. So it has 7 oxygen. So by adding water, what have we added? We added hydrogen, right? How many hydrogens? 7 times 2, 14 hydrogens. 14 H plus, right? So the hydrogen comes as an acid. Okay, so you add 14 H plus into the other side. 14 H plus. Okay, now all the atoms are balanced. What do we do next? We balance the charges by adding electrons. Okay. Now let's see. There are 14 H plus, meaning 14 plus charges are here. And in the dichromate ion, there is negative 2. Do you see that? Okay. So here you have 14 H plus. Here you have negative 2. On your reactant side, you have 14 plus and negative 2. What is the total going to be? Plus 12. So the charge on the reactant side is plus 12. What's the charge on the other side? Here you have 2 chromium 3 plus. Each chromium charge is 3 plus. If you have 2 chromiums, what's the charge going to be? 2 times 3 plus plus 6. Now water is a neutral molecule. There is no charge. So because of that, there is no charge coming from the water. So in our reactant side, we have plus 12. Product side plus 6. What happened? Is it oxidation or reduction? Remember, the oxidation is increase the oxidation number. Reduction is you reduce the oxidation number. Going from plus 12 to plus 6, is it increasing or decreasing? Decreasing. Right? If it is a decreasing, is it oxidation or reduction? If the oxidation number decreasing, that's a reduction. Meaning plus 12 to plus 6. Reduction meaning it had gained electrons. How many electrons has it gained? So you are going from plus 12 to plus 6. Oxidation number decrease. If the oxidation number decrease, that's a reduction. Reduction, right? So reduction mean, remember, oil rig. Reduction is gain electrons. How many electrons you need to gain? Electrons meaning you are adding negative charges. How many electrons do you need to gain in order to go from plus 12 to plus 6? 6 electrons. 6 electrons. Remember, the charge of the electrons are negative. So plus 12 and minus 6. That is plus 6. Now it is similar to plus 6 on the other side. Okay. So that's why you are seeing 6 electrons right there. You add electrons, 6 electrons. So can go from plus 12 to plus 6 by gaining 6 electrons. So basically, what is dichromate ion undergoing is it is the reduction. Right? So this is the reduction half reaction. Dichromate is reduced and is oxidizing agent. If that is the reduction, that is the oxidizing agent. Oxidation number decrease from plus 6 to plus 3. That is for chromium. I was explaining here for the whole process. But if you look at the chromium, it is going from plus 6 to plus 3. Okay. Now, what does it mean? It goes from plus 6 to plus 3. Remember, how we calculated oxidation numbers. Let me remind you about it. Cr2O7 charge is -2. So we said 2 chromium ions. So in this charge, this whole complex charge is -2. So 2 chromium ions plus 7 oxygen, their charges when it adds up should equal to -2. -2, that's what it means. The charges of chromium and oxygen when it adds up has to equal to -2. So oxygen, we know charge of the oxygen is -2 unless it is in a peroxide. So this is not a peroxide. Peroxides, oxygen charge is -1. In all the other compounds, oxygen is -2. Okay. So 2 chromium ions, and then there are 7 oxygen. 7 times oxygen is -2 equals -2. So 2 chromium ions, 7 times 2 is 14 equals -2. So 2 chromium ions, therefore -2 plus 14 plus 12. It's just basic math, right? So 2 chromium ion charge is 12. So then what should be the charge of 1 chromium ion? 1 chromium ion would be 12 over 2 plus 6. That's why oxidation number of chromium decreased from +6. That's how you get the +6. And here it is 3 plus 6 to 3. So chromium is undergoing reduction. Okay. Now let's look at the other half reaction, which is iodide going to iodine. So we need to balance it. I minus I2. So since it's iodine, there are 2. You need to add 2 here to balance this 2. 2I minus I2. We don't have any other atoms to balance. Then we're going to look at the charge. So 2I minus, meaning on your reactant side charge is -2. And then so this side is -2. Iodine by itself is 0. -2 to 0. What happened to the number? Oxidation number increased. Right? If the oxidation number increased, it is a oxidation. How do you go from -2 to 0? By losing 2 electrons. So since it's a loss, 2 electrons, its oxidation goes to the product side. Okay, this is the oxidation half reaction. I minus is oxidized and is the reducing agent. Oxidation number of iodine increases from -1 to 0. Right, it goes from -1 to 0. Now we have 2 half reactions. What we need to do is we need to balance our electrons. So in the iodine half reaction, there are 2 electrons on the right hand side. For the chromium one, we have 6 electrons on the left side. 6 and 2. We're going to add these two together, these 2 reactions. So then we need to make sure they both have the same number of electrons. So we can cancel the electrons when we are adding. In order to do that, we need to multiply this equation by 3. 3 times 2 is 6. So that's what we're going to do next. Multiply each half reaction, if necessary, by an integer so that the number of electrons lost in the oxidation equals the number of electrons gained in the reduction. The reduction half reaction shows that 6 electrons are gained over here, where this one. 6 electrons are gained. The oxidation half reaction shows only 2 electrons being lost. So we have to multiply it by 3. This whole reaction we multiply by 3. 3 times 2I minus 6I minus 3I2, 6 electrons. Now that we have the same number of electrons in the both half reactions, you add it together. When you add it, electrons will get cancelled. Always cancel. Add the half reactions, cancelling substances that appear on both sides. and include states of matter, electrons must always cancel. So you cancel these. So overall reaction would be 6I minus 14H plus dichromate ion, 3 iodine solid, 2 chromium ions and 7 liquid water. So this is aqueous soluble in water, and then these are the 7 water molecules that generate due to this reaction. And then the iodide would be solid, dichromate ion soluble in water, aqueous. H plus comes as the acid, 14H plus, it could be your hydrochloric acid HCl, and then iodide, aqueous. Okay, so this is going to be a balanced equation, and this is how you balance a redox reaction. So what are the steps? First, separate them. Separate the skeleton equation to oxidation and reduction half reactions, and then each one you balance the atoms. You balance oxygen and hydrogen last. After you balance atoms, you balance the electrons, and then you do the same thing for the other one, and then check to see if the both sides have the same electrons. If not, you need to multiply one or somehow make both electrons equal so they can cancel when you add the two. You add the two oxidation and the reduction reactions, and then finally you include the state of matter. Okay, so that is how you balance a redox reaction in an acidic medium. We perform reactions in basic solutions too. So what do we do when you are balance a redox reaction in a basic solution? An acidic solution contains H plus ions and water. We use H plus ions to balance hydrogen atoms. Remember, we use H plus. But in a basic solution, we have hydroxide ions and water. To balance hydrogen atoms, we proceed as if in acidic solution, and then add one hydroxide ion to both sides of the equation. We'll do with an example so you'll understand what it means. For every hydroxide ion, every hydroxide ion and H plus ion that appear on the same side of the equation, we form a water molecule. Okay, so we perform the reaction balancing as if we are doing it for the acidic solution, and then what we're going to do is we add hydroxide ions to both sides, and then with OH minus and H plus we make water molecules. I'll show you with an example what is this process. Excess water molecules are cancelled in the final step when we cancel electrons and other common species. Okay, here's a beautiful example. Permanganate ion reacts in both basic solution with oxalate ion. So this is permanganate ion, this is oxalate ion, to form carbonate and manganese oxide. Balance the skeleton ionic equation for the reaction between sodium permanganate and sodium oxalate in basic solution. In this reaction, we are only given the ions, but the ions cannot exist by itself. It has to have a counter ion. So manganate comes as sodium permanganate, and oxalate comes as sodium oxalate. Okay, we follow the numbered step as described in the text. Okay, we're going to do the same thing now. First, we divide the reaction into half reactions. Remember, we had to choose what are the two half reaction: MnO4 minus MnO2, C2O4 minus 2, CO3. So this is one reaction and this is another one. These are the two, right? We can first try to balance this guy here. 1 manganese, 4 oxygen, 2 oxygen. Okay, so since there are 2 oxygens, we first balance other than oxygen and hydrogen 1, and for this one there are 2 carbon, there's 1 carbon here, so we have to add 2 to this side to balance the carbons. And then we're going to balance oxygen atoms by adding water molecules. 4 oxygen, 2 oxygen. How do we balance oxygen? By adding water. So we add 2 water molecules here. There are 4 oxygen here. 2 times 3, 6 oxygen there. 4 and 6. So we need to put 2 water molecules to the left for this one. Then we balance the hydrogen atoms by adding H plus ions. So we put 2 water molecules. So 2 times 2, 4H plus. So you put 4H plus to this side. To this one, 2 times 2 again, 4H plus. What are we going to do next is you're going to balance the charges by adding electrons. Now let's see here. 4H plus meaning 4 positive charges. And then you have negative 1 MnO 4 minus. So 4 plus minus 1. What is the total charge going to be? Plus 4 minus 1 plus 3, right? So this side, let me find my pen. Come on, pen, where are you? Thank you. 4H plus minus 1. So plus 4 minus 1 equals plus 3. So the total charge for this side is plus 3. This is 0, this is 0. So plus 3 going to 0. Oxidation number decreases meaning it's a loss. So you have to add 3 electrons to balance. So that's why you have added 3 electrons here. Okay. What about the other side? Water neutral molecule 0 charge. Here you have minus 2. And from this side there are 2 carbonate ions. So 2 times 2 minus minus 4. And 4H plus plus 4. So minus 4 plus 4 gets cancelled. So this side meaning it's going from negative 2 to 0. Negative 2 to 0 meaning number increases. If the oxidation number increases, that's oxidation. Loss of electrons. So the 2 electrons need to be lost and you put that in the right side. Right? So once you balance the charges, we have 2 electrons here. Sorry, we have 3 electrons in the manganate one, and oxalate one we have 2 electrons. Now we need to balance our electrons. So we have to multiply each half reaction so that we have the same number of electrons. You multiply this one by 2. So when you multiply it by 2, everything need to be multiplied by 2. So the electrons would be 2 times 3, 6. Hydrogen 8. 2 manganate. 2 manganese oxide and 4 water. And then the other equation, the second one, we need to multiply by 3. So 6 water, 3 oxalate, 6 carbonate, 12H plus, 6 electrons. And then you add the 2, cancel the electrons. And then if you have any hydrogen ions and the water molecules in the reactants and the product side, we can cancel and subtract or add as needed. So 6 electrons cancelled. 8H plus on the left, 12H plus on the right. So 8, 12. So this would end up 12 minus 8, 4H plus on the right side. and then the water, 4 water here, 6 water here. So 2 water will end up in this side, 6 minus 4. And these would remain as it is, 2MnO4 minus 3 oxalate, 2 manganese oxide, 6 carbonate. Now remember, we are still in acidic medium, but we need to do this in basic medium. Once you get to this point where you balanced everything, just as if you are doing it in acidic medium, and once you come to that point, you add hydroxide to both sides of the equation to neutralize H plus and cancel water. Now this is our equation, 2 manganate, 2 water. So you're going to be adding hydrogen ions to both sides. So you see here, not hydrogen, hydroxide. So there are 4 H plus. To make water molecule, you need another 4 hydroxide. When you're adding hydroxide, 4 hydroxide, you have to add to both sides. So there are 4 here. So you add 4 hydroxide, and you're going to be adding 4 hydroxide to this side also. That's what we are doing here. Originally you had 4H plus, so you add 4 hydroxide. You add the same 4 hydroxide to this side. And then 4H plus and 4OH minus makes 4 water molecules. This side you don't have H plus because we cancelled earlier. But there are some 2 water molecules here. You have 4 here, 2 here. So 4 minus 2 will end up having 2 water molecules. So at the end you will have this equation where we have hydroxide ions in the balanced equation without any H plus, since we are doing this reaction in basic medium. Okay. Beautiful steps, kind of a lot of steps, but once you understand how it is being done, it's just like putting a puzzle pieces together to get the final answer. You can do it stepwise. Okay. All right. We'll stop here.